Welcome to Discover Daily by Perplexity, an AI-generated show on tech, science, and culture. I'm Alex.
And I'm Sienna. Today we're taking a fascinating look at how a tiny single-celled organism is helping solve one of biology's oldest questions. Did the chicken or egg come first? But first, let's look at what else is happening.
Starting with Pokémon Go, it turns out those fun AR catches have been helping build something much bigger. Niantic, the company behind Pokémon Go, has been using player data to develop what they call a Large Geospatial Model. Through features like Pokémon playgrounds and location scanning tasks, players have helped map real-world locations across North America and Europe, creating detailed 3D maps for augmented reality applications. The system currently covers more than 10 million scanned locations, with approximately 1 million new scans being added every week. While players can manage their privacy through in-game settings, privacy advocates are raising questions about whether users fully understand how their gameplay data contributes to AI development. This data collection is particularly significant as Niantic uses it to help computers better navigate and understand physical spaces, laying groundwork for future AR and wearable technology applications. In mid-November 2024, 2 critical undersea telecommunications cables in the Baltic Sea were damaged, raising serious concerns about the security of vital international infrastructure. The first cable affected was the Sea Lion 1, a 1,200-kilometer fiber optic link connecting Helsinki, Finland, to Rostock, Germany. Sea Lion 1 is a crucial high-capacity data highway that enhances connectivity between Central and Northern Europe. The Sea Lion 1 cable ceased functioning on Monday. Just a day earlier, a 218-kilometer internet link between Lithuania and Sweden's Gotland Island went down. These 2 cables intersect physically at the same location on the seabed, and both were damaged at precisely this crossing point. As a result of this, both Finland and Germany issued a joint statement expressing concern about hybrid warfare by malicious actors, with German Defense Minister Boris Pistorius explicitly labeling this as an act of sabotage. The German government's stance is based on several factors. First, the precise nature of the damage suggests deliberate action rather than accidental causes like ship anchors. Second, the timing and location of the incidents, affecting 2 separate cables in quick succession, raise suspicions of coordinated interference. The response to this incident has been swift and multi-layered. NATO has announced its strengthening protection of undersea infrastructure in response, while the European Union has called for an urgent investigation into the incident. The event underscores the vulnerability of our global communications network and the critical need for enhanced protection of undersea infrastructure. As we rely more heavily on these cables for everything from internet connectivity to financial transactions, ensuring their security becomes paramount to global stability and economic well-being. Now to Sienna for our deep dive.
In 2017, a tiny organism named Chromosphaera perkinsii was discovered in Hawaii. Now, scientists have made a remarkable finding that provides new insights into early multicellular life. This tiny organism, which diverged from the animal lineage over 1 billion years ago, is showing us unexpected complexity in single-celled organisms. What makes C. perkinsii special is its ability to form multicellular structures during reproduction. When it reaches maximum size, it undergoes a process called polyntemy, dividing into multiple connected cells and creating colonies that persist for about 1/3 of its life cycle. These colonies contain at least 2 distinct cell types, a level of organization previously unexpected in a single-celled organism. The genetic analysis is particularly telling. C. perkinsii expresses genes that we typically associate with animal development, including ones involved in cell adhesion and signaling.
So what does this tell us about early life on Earth?
Well, it suggests two possible interpretations. First, the genetic tools needed for complex multicellular development might have existed long before animals emerged. Alternatively, these mechanisms could have evolved independently in C. perkinsii. Either way, it challenges our understanding of how complex life evolved. What's particularly interesting is that this discovery could shed new light on those mysterious 600-million-year-old embryo-like fossils that scientists have struggled to understand. The presence of these sophisticated cellular mechanisms in C. perkinsii provides a potential model for how such structures might have formed. When we look at C. perkinsii's colonies under a microscope, we can see cells working together in ways that are reminiscent of early multicellular organisms. Some cells specialize in specific functions, while others maintain the colony's structure. Intriguingly, these colonies can form a central cavity similar to a blastocoel in animal embryos. This discovery may alter our understanding of life's evolution and could lead to investigations of similar mechanisms in other single-celled organisms. The team's ongoing studies on how these multicellular structures respond to various environmental conditions may offer insights into early life adaptation and evolution. While these findings are exciting, they don't conclusively answer questions about the origins of animal embryogenesis, but they do open new research avenues and challenge assumptions about single-celled organisms' capabilities.
That's it for today. Thanks for tuning in, and don't forget to subscribe on your favorite platform. For more info on anything we covered today, check out the links in our episode description. And don't forget, you can now access Perplexity's AI-powered knowledge base on the go with the mobile app, available for both Android and iOS. We also just released the Perplexity desktop app for Mac OS. In other Perplexity news, we're thrilled to share that Perplexity just launched an exciting new AI-powered shopping experience. The platform now offers one-click checkout with Buy with Pro, free shipping for Pro users, and a cool new Snap to Shop feature that lets you search for products just by taking a photo. We'll be back with more stories that matter. Until then, stay curious.